Okay, in this video, we're going to look at solving quadratic equations by completing the square, which is really going to be a combination of kind of two things we've already done. We've already looked at completing the square, and we've already looked at quadratic equations, so we're just going to put those two things together. So the way we're going to start off is we're just going to look at two equations, so parts A and B, and we're going to solve each of these quadratic equations. So notice each of the equations is in different forms. This first one here is in what we call the standard form. Okay, so standard form just means that you have three terms. The first term is an x squared term, the next term is an x term, and the last term is a constant. So that's in standard form. And the last, or in part B, it's in vertex form. So vertex form is where you have the one term at the x minus or plus some constant squared times a number plus or minus another number. So when it's in standard form, we learned the technique of factoring. So solve by factoring. When it's in vertex form, there's only the one x that we can see in the equation. So we saw that we can solve by isolating. Okay, so let's try this first one. Let's try to solve by factoring for this quadratic equation, which is in standard form. And in order to do that, we have to do kind of our sum product. So the sum it's the middle coefficient, so minus 4, and the product will be the product of the A and the C, the first and the last number. So 2 times minus 7 is minus 14. So we're trying to think of two numbers that will add to negative 4 and multiply to negative 14. And I'll give you a second, try to think of that, but the problem here is that there aren't two numbers. There aren't two nice integer numbers. Right? So there actually might be numbers, but they're going to be like decimals. So there's not two numbers that we're ever going to think of. So this doesn't factor over integers, meaning that we're not going to be able to come up with the numbers. So that creates a problem, and it kind of means we're stuck. We can't solve this equation, at least using techniques we have. So we can't, so it doesn't factor. Meaning you can't come up with two numbers. So let's put that one on pause, and let's go to B and see how we would solve B by isolating. So to isolate, all you have to do is get the x by itself. So we're just going to rearrange x squared is 9. So you got to add 9 to each side here. So often, this step, you kind of all do it once so that the 9s go away. Then we have 2x minus 1 squared equals 9. And then we'll divide both sides by the coefficient 2. Now notice on the right side there, 9 minus 2 is not a whole number. So you got options. You can leave it as a fraction, which we often will do, or you could write it as a decimal. I'm going to leave it as a fraction and not change it to a decimal until the very end. Now, you could do a decimal here, like 4.5, which is not that big of a problem, but the problem would be, like, what if it didn't divide nicely into a nice terminating decimal? What if it was an infinite decimal that repeated or something, in which case we couldn't write it down. So we'll leave everything as fractions. Now we've got x minus 1 all squared, so we take the square root of both sides. Remember, when you take the square root of both sides, you have to consider both the positive and the negative. And again, I'm going to leave the right side there as, I'm not going to get a decimal. So square root of 9 over 2 is not a nice square root. Right? You can take the square root of 9, but you can't take the square root of 2. So we'll just leave it like this, square root of 9 over 2, plus or minus the square root of 9 over 2. And now we've done this before. We actually have two equations. We've got one with the positive and one with the negative. So this actually creates two equations. You've got x minus 1 equals, say, the positive root, so square root of 9 over 2, and x minus 1 equals negative square root of 9 over 2. And now you can just solve each of these by adding 1 to each side. So x equals, so we have root 9 over 2, and then plus 1. And then for the second one, we've got x equals negative root 9 over 2 plus 1. So there's two answers, square root of 9 over 2 plus 1, and negative square root of 9 over 2 plus 1. Both of those would be, we could get decimal answers. These answers here are what we call the exact roots. So these are exact, meaning we haven't rounded. But if we want to round, we would get the approximate roots. The approximate roots are, so the advantage to the exact roots is they're exact. It's the actual correct number. But in this case, that the exact root has a decimal in it, or not a decimal. It has a square root in it, which it's hard to see exactly what that number is. Where if you take the square root, so square root of 9 over 2, so you just put that into your calculator, and then add 1. If we round to 2 decimal places, this would be x equals 3.12, which is approximate. I've rounded. It's actually 3.1213203, right? And there's a whole bunch of numbers here. And then you could do the same for the second one. So again, square root of 9 over 2, but that has to be a negative number. And then add 1. So here you're going to get x equals, and again it's going to be approximate, negative 1.12. Okay, so those are your two approximate answers. So in this one we were able to solve, right? So in question B we were able to solve, whereas question A we weren't able to solve because we had to factor. Now here's kind of the thing that's interesting here. Interesting, but here's kind of what is going to connect to what we're doing, is these questions are actually the same. They're the same quadratic equation, they're just in different forms. How do I know that? Well, if we took this and we completed the square, so remember, completing the square changes from standard form to vertex form. So if we complete the square on this one, we'll actually see it's the same as in part B. So we'll do that. So you have to remember the steps to completing the square. So if you remember, it was I think we had it as a 5-step process. So the first thing you do is you group the first two terms. So step 1 is you put brackets around the first two terms. Step 2, you common factor the coefficient a. So whatever's in front of the x squared gets common factored. So that would be x squared and then minus 2. You divide 4x by 2, you get negative 2x minus 7 equals 0. And then you add and subtract half of the middle term squared. So half of -2 is -1, and then if you square it, you get +1. So we're going to put +1 and -1. Just realized I have a 0 there. I don't know why it was an X there. That should be a 0. I'm trying to be tricky. And then we want to take this last term outside the bracket, so we need to multiply it by the coefficient a. So that would be 2x squared minus 2x plus 1 minus 2 minus 7 equals 0. And then the final step is to factor this trinomial, which will always factor as a perfect square. So it turns out it's x minus 1 squared. The square root of 1 is 1, but it's negative because of that sign there. And then you just add these two terms, or collect like terms, so it's -9. So notice it's the same as the one in part B. Right? So same equation. So the reason we did this, so the reason I did both these examples and tie them together is, let's say we're given an equation in standard form that we can't factor. Well, how are you going to factor it? The answer is you're going to do exactly this. You complete the square so that it turns into vertex form, and then you can always solve by square rooting, or by isolating, which involves square rooting. So in order to solve a quadratic equation which does not factor, let's write this down as a rule. So to solve a quadratic equation written in standard form, that does not factor, we can complete the square and then solve by isolating. So what I'll do here is I'm going to give you an example. So there's an example of a quadratic equation, and I want you to try to solve it. So you're in a standard form, so you would try factoring. I made it so it's not going to factor. So you're going to use the technique that's outlined here. So the first thing you have to do is complete the square to get into vertex form, and then isolate. So what I'm going to do with the video here is I'm going to pause it and let you do the steps. So what I want you to do is complete the square, and then isolate. So I'll pause it, let you guys do the questions, and then I'm just going to put the answer up here. So I'm not going to walk you through the answer. I'm just going to put the answer on the screen. Okay, so if you complete the square, that's what it would look like. And now you need to isolate. So again, I'll pause it, and I'll let you guys do it, and then I'll put up the answer. All right, and there's the part where you isolate, solve by isolating. So I got two answers. I got exact answers and approximate answers. So now I posted a few questions. So if you guys go on, do those, and then upload your solutions.